this up. All right, recording has begun. So we're going to start on page 32 here. It's called, this first page is called Mixed Practice because it's just a mix of what we've done already. And by what we've done already, of course, I mean we've done parabolas, we've done circles, we've done ellipses, and we've done hyperbolas. And all the equations are right there on the page. Some notes are given to you. For example, let me get back to my regular colors. If this was a parabola, you'll notice it has the y squared, which means that it's going to go left and right. In this case, it has x squared, which would mean up and down, left and right, or up and down, depending on if it's positive or negative, yeah? So I don't really want to make the sketch there. But remember, parabolas are just like, they kind of look like half a hyperbola. For circles, really the only important thing was the radius, because the numbers in front of the x squared and y squared are the same, or there's nothing there, actually, really. For ellipses, what we needed to look at was the major axis. So we go looking for A. I'm not going to make too many notes about that because I made the notes earlier in the course, in the unit, but I will make other notes on it later when it comes up. And then in hyperbola, the important thing is look and see which one comes first, x squared or y squared. If x squared comes first, then the hyperbola crosses the x-axis, so it looks like an x. That one I will sketch. If it looks like that, it looks like this. Sorry, if the x comes first, it looks like this. If the y comes first, it looks like this. And if you've been following along, this is not new, but it is always nice to see things in a few different ways, a few different times. Because just because I say it doesn't mean you get it. And even though you might have understood it yesterday, maybe you don't understand it today because it's all gotten mixed up. Or maybe when I said it before, you didn't understand it. And now that you've done some practice, it's making more sense. Okay. So hopefully today we'll bring the ideas together in your head and you'll be well prepared for tomorrow. Okay. Let's get started. These questions are all done by Tom, but they're very fast, so I'm going to do them again. I'd like you to just take a look at what the question says. It says, describe the curve, which means we need to say, okay, does it open up or down? Does it open left or right? Blah, 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 blah. Identify the type of curve. So is it a parabola, circle, ellipse, or hyperbola? Tell me what its center is or its vertex. Of course, the center is for the circles, hyperbolas, ellipses. The vertex is for parabola. So let's just get started. I want to try and teach you how you would note what type of curve this is. So like, just, I'll throw it out to you. This first one, which of the four types do you think this is? This one in A here. Which of the four types of conic sections is this? Okay, Tarek, you think circle. I'm going to say it's not a circle because remember with circles, let me just go back to my note here. With circles, we should see two squared values. X and Y should have squared things going on, and we do not see that here. So that's right out. We can't have a circle. We had noticed with ellipses, we have the same case. We have squared values. With hyperbolas, we have the same case. X and Y have squared values. So we actually only have one choice. What's it going to be? It's going to be parabola. Yes, exactly. So it's a parabola. It's a parabola because we see a squared and we don't see a squared there. So I'll make a little note of that. You see y squared, and then there's x linear. That means it has to be a parabola, and that's going to be y squared form. So we already know that it's going to move either left and right. Well, sorry, it's either going to open to the right or open to the left. And let's see, if this is y squared form and this is a positive number, it's going to open to the right. So it's a parabola. Let me just note the vertex before I write that. Vertex is, what is it? What's the vertex? It's h then k, the x one and the y one. So -1 and 2. And it will open to the right. And if you don't remember that, notice it's y squared form, so it should open like this because we have a positive p value. Maybe you don't even remember what the p value is The p-value is this. This is for p. So positive, it's actually 1. P-value is 1. That's for p. So remember, there's a lot to remember, but that's why I'm reviewing this. It's a good review of what we've done so far. So all the pencil stuff is extra bits for you to note. All the black stuff is things that you should write down to answer the question. So have we done what we said we're going to do? Well, I identified the type of curve. I gave the vertex. I described the curve. And so I've finished the question. There's no other fancy stuff to do for this question. Okay? Clear on that? Everyone caught how I noticed how it was a parabola and not something else? It's a parabola if one of the terms is squared and one is not. One is squared and one is linear. Those are the differences. The reason that how I knew it opened right is because I looked at the term in front of the linear value, the x in this case, and it opens to the right. So we did that at the beginning of the unit. Okay, let's play this little game again. Which of the 4 types is it? Is it a parabola? No, because it has 2 squared values. Tadek, you're saying it's an ellipse, and I agree with you. It has squared values, and there's different fractions on bottom, and the plus. The plus is super important. If it had a minus, what would it be? Well, it would kind of go inside itself and become a hyperbola, right? It kind of like explodes outwards if it's a minus in the middle. So yes, perfect. It's an ellipse. It has a center. The center is given by the x, what terms are next to the x. So -4 and 1. And then it doesn't open right or left because that's not how ellipses work. It'll be sort of stretched, or the major axis is in the x direction. So I'll just say stretched in x direction. And what I mean by that, if you just wanted to draw the sketch, it would look like this, yeah? Because A, that's the bigger number, that would be a squared. So it's related to the x, it means that it would be stretched in that x direction. Don't get confused with the hyperbola stuff we came up with before. So that would mean this, just in case you're thinking about it. Now, how do we know it's an ellipse? I know that it's x squared plus y squared form. And one way I actually like to write this down, well, actually, that's probably enough. X squared over a squared plus y squared over b squared form equals 1. My laptop is flying out today. Hopefully that's okay. We can see it matches the form. Really, just look at the table and match it directly. This, if you look really carefully, matches this form pretty much exactly. It's got the x in front, it's got an a on bottom, it's got the y stuff after that, and the b on bottom, and then it equals 1. So it's clearly an ellipse. There's hundreds of ways that I can explain that, but just look up and take a look. You should get it pretty easily. Okay, let's keep going. Something stuck in my throat today. So C, what do we think? Let's take a look at it. This could be a very good multiple choice. You know, look at the equation, tell me what the shape is. Bam, you got the mark. Hyperbola, 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 hyperbola. There is only one thing you need to look at, and it is this minus. Plus, 1 is plus, 1 is minus, and it all equals 1. Of course, it's hyperbola. So it has this x squared over a squared shape minus y squared over b squared. And it has 2 different forms, but the important thing is that you have the minus in the middle. That's the important part. So it's definitely in a hyperbola. Let's see if we can get the rest. Hyperbola. What's the center going to be? It's given directly here. It's going to be the x1 and the y1, 1 and 2. And finally, how do we describe it? Maybe you don't know how to describe it. Maybe you would just be able to give me the picture. And yeah, I was going to say, Ted, I had a good way to show that before. It's like this shape, which is, I like to call it, it looks like an X to me. So it's the X first type. There's different ways of calling that. You can think of it as X positive. The X term is positive. So, you know, you have a positive x squared term in front. I like to think of it, if the x comes first, it looks like an x. If the y comes first, it looks kind of like a y, or whatever you want to call it. that way. Someone called it an hourglass or a sand timer yesterday. Whatever reminds you of what's correct. I think they said sand timer because, you know, with the sand timer, you have all this sand in this one, and it kind of falls down into that one. So whatever gets you through, but just see what you can do. And that rhymed. Okay, what's the next one? How do I know? Circle, okay. There's a couple ways that we know that it's a circle. First of all, it's the only type really that has, yeah, that R on the other side. We can see that clearly here, we have a radius. That would mean that R equals 5. So if it has a radius, that's a huge hint. The other thing is that these numbers in front, in this case 1, are the same number. In this case 1, like I said, but later we'll see if they have, the, you know, if it was 2 and 2 or 3 and 3 and 4 and 4, they would actually, that would be fine. That would be the same. But the important thing is that you have the x squared plus, of course, the plus, and then it equals a radius squared. That's the big difference. Some of you might mistake it for an ellipse, and that's because a circle is a special case of the ellipse. You know, the ellipse is the general case. It can be stretched any which way. The circle is just a really nice special case of the ellipse. Instead of being stretched, it's back to normal. And we can see that that's just, for example, if we look at the ellipse cases, if we were to set these equal to the same number and then multiply over by this, we would get the circle back. Let me just quickly write that for you. So let me say, let's just say I had this. Right? This is an ellipse. I know it's an ellipse because it's in that elliptical form. But really, these numbers on the bottom are the same. So if I was to multiply everything by that, you know, multiply this by 6, multiply this by 6, multiply this by 6, that would cancel these out. And you would get, dun, 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 you would get the circle shape. So an ellipse is a circle, or I should say a circle is an ellipse, just a special case. You don't need to know that necessarily. I just wanted to make the connection. So let's go back to what was asked. Yes, it's definitely an ellipse. Ellipse. It has a center. Of course it has a center at -4 and 2. And then we should be able to describe what it looks like. Well, we don't really need to draw the circle. We know what a circle looks like, so we should probably just say the radius is 5. We can draw it. Let me cheat because I can. And it's a circle. Okay, so these are our 4 types. So now we know how to, well, you might not know how to pick the formulas, but if you've been following, it's not too much effort to pick the formulas. Now, again, the stuff in black, what I've written in black, is really the final answers. The other stuff, the pencil and the highlighting, all that, that's just me trying to help you understand where my answers came from. But you kind of just need to be concerned with getting the black answers. Simple? Or do you want me to show you any other type of example? It's a circle. Oh, shoot. Thanks for catching that. Circle, thanks. I was thinking about this, sorry. It's a circle is a special case of the ellipse. But yes, definitely circle. Thank you, Aisha. I almost made a mistake there. But okay, so that was a fine question. Anyone else have any questions on how I got any of these pieces? Really, it's 3 different things for each one, yeah? Type, center or vertex, and something special that describes it. Very quiet today. Are we okay? Are we all lying down in bed? We're too tired to interact? What's going on here? Gonna move on.
Everything okay, everything.
2, 1. Okay. So this next section, I don't really like how it's introduced. The reason I don't like that is because it kind of expects you to think too much. And you can do it this way. This topic can be done by doing the steps that it is telling us about. But I'm going to try to make it easier, okay? So first of all, what does really matter is this. So what it's saying is that every one of the conic sections that we've covered so far can actually be written like this. If we were to move things to one side and multiply by common denominators and things like that. But this is like what we call our general second degree equation. Second degree just means we have squareds. And of course, it's an equation because it's equal to 0. Or equal to something. I don't need to write that actually. So it's just saying that all of them have the same general equation. And if we remove pieces, we get different shapes. And it's saying things like, look, if we had A equals C, B equals 0. So if that meant this term and this term were the same, and this was canceled, it would actually give us a circle. But again, that's way too much to remember. So as we go through it, I'm going to give you tips for how to figure this stuff out. And if you want to use this as a reference, you know, as I say back in Newfoundland, fill your boots. You know, knock yourself out, have fun. But it's not, you don't need it to solve this. So I'm just going to move on. What we do need, because we're going to be given equations in this form, and we need to make it into the form that we were using before, you need to be able to complete the square. Now, some students hate completing the square, but honestly, especially for this question, this type of question, it's going to be very simple. Because all we're doing, we're creating what's called perfect square trinomials, which means we're going to transform this stuff into this stuff. We're going to take a 3-term thing and make it into a 2-term thing. And there's steps for that, which you can look at later, but I'm going to give you a quick example. So just follow me here. We are going to complete the square, and that's to get it into the form we want to. So I'm going to just review how to do a quick complete the square, and then we'll go ahead. So let's just say we had x plus 2 all squared equals 1, okay? Let's just say we had that. And I wanted to expand that left side. Well, I would multiply it by itself, yeah? So really it's this. This is not completing the square yet, I'm just showing you something. So x squared plus x squared, and then you'd have 2x and another 2x, so that's 4x's. And then you'd have 2 times 2. This is a bad example, let me just restart it, sorry. Let me make it a 3, so it's clear. Okay, you have the same thing squared, x plus 3 squared. Multiply it by itself, you'll get x times 3 and x times 3, so 6x's plus 9, and that equals 1. Okay, what completing the square does is it does something like this. Let me just mess with you for a second. This is a fully completed question. Let's just say, for the sake of argument, that we had x plus 6x. Okay, let's just say we had that, and we had that equal to 0. All right? So this is a new example. I'm just trying to make some connections. Just stay with me for now. Let's just say that this was our case, all right? Or we can put any number here. I don't know, let's put the number 7 for fun, okay? That number on the left, or that x stuff on the left, in order to solve this, we need to make it into what's called a perfect square. And in order to do that, we need to make it so this could look like this. All right, or in other words, we need to make it into a perfect square trinomial. It needs to have 3 terms. So let me go ahead and do that. I'm going to show you what I mean. If this is not new to you, that's a good thing. So we would write this, and we would write this. We write those 2 terms again. What we need to do is we need to take this number, and we need to divide it by 2 and then square it. We need to divide it by 2 and then square it. And put it next to it. Divided by 2 is 3, squared is 9. What that does is it allows us then to put it into a squared form, but I'll show you that in a second. Now the problem is, I've added a 9. Notice this. This and this are exactly the same. I can't just add a 9 for free. That's not how math works. So instead of just adding a 9 for free, I put another 9 on the right side. And then I'm okay, it's still balanced. I added a 9 to one side, I added a 9 to the other side, and everything's cool. All right, and now we simplify. So just follow me here. This, what I need to do is, well, technically I need to factor it. How would I factor that in terms of, you know, what multiplies? Let me write it this way. I'll show you the full thing and then I'll do the shortcut. What two numbers multiply to make 9, but add to make 6? 3. And it'll always be the same two numbers in this case. So you get this, all right? We get this, and then that's clearly x plus 3 all squared. So the right side I'll simplify, it gives us 16. And that means finally, it must be this. There's a faster way to do this. I'm just showing you all the steps. So what did we do? Here we started with a kind of ugly equation. It didn't give us much. I completed the square here by dividing the middle term by 2 and squaring it and made a 9, added it to the other side. And then I actually could go straight from here. If I divide this by 2, I just put it there. Okay, I'll explain that more in a second. I just want to show you what we're doing with this, and I hope I didn't confuse you all. The long story short is that this equals this. Okay, let me go ahead and do it in context so you can see where I'm going with this, because I don't want to confuse you. These are your steps. So I'll just quickly read through them because they're going to be important. Steps for completing the square, for this topic anyway. Collect the x's and y's together. You'll see what that means. Move any constants to the right side, so any numbers on their own move to the right. If x or y squared has a coefficient that's not 1, factor it out. Complete the square, and then write the equation in standard form. So let's just go ahead and do it. Example 1. Let's take a look. We have x squared here. We have negative 6x here. We need to collect those, put them together. So we have x squared minus 6x. All right, we've collected the x terms. Now let's collect the y terms. We have a y squared and an y squared and an 8y. And then I'm moving the number to the other side. So let me color code this. My x's, my colors are all messed up. My y's, and then I'm going to move the constant to the other side, which is 24. That is not completing the square, that is just grouping things, okay? Now I can see that in front of the x squared, I don't have a number. In front of the y squared, I don't have a number, so I'm okay, I'm safe. I can start completing the square. Look at this. Group all the x's together, use brackets. So you can go ahead and add the brackets here. Now this is where the magic happens. Are you ready? I love how this works out. I don't know why I like it so much. I think it's because it's easy. The brackets here, x squared minus 6x, leave a little space. We're going to put a number there. Here, leave a little space, and then 24. And then are you ready for this? Are you ready? Let's do it. 6, or negative 6, divided by 2 and squared. What's 6 divided by 2 is 3, square it, 9. 9. What do? We multiply by whatever's over here, that's just a 1, and we put it on the other side too. Now it's balanced. Let's do it again. This one, 8, divided by 2 and square it. 8 divided by 2 is a 4, 4 squared is 16. So now we add 16 to the other side. If there was a number out here, we would have to multiply by that, but we don't have to do it in this case. Okay, now it's going to go and become something nice. Last thing, and the steps are always the same, so you get really good at it. This is x minus 3 squared. How did I get that minus 3? I just take this number, divide it by 2. It's just how this works. You can also factor it if you want to. You can take this and you can factor it normally. What two numbers multiply to make 9 and add to make negative 6? It's negative 3. And what about this one? What's it going to be? What's it going to be? What's it going to be? It should take you 1 second to say it. Y plus 4. All squared. The right side, what's 24 plus 9? plus 16, 24 plus 9 plus 16, 49. 49. I'm done. I'm done the perfect square part, or I'm done the completing the square part, I should say. So this is done. This equation has been completed. I'm not going to continue the question yet until we're clear on what's going on. So does anyone have any questions on how I got anything here? Because we're going to do it again and again. Okay. Good. Right, so let's make sure that we've answered the question. First of all, it said write this in standard form. So let me go back a second. I'm just going to scroll up. What we were given it as is a general second degree equation. That's our general equation that works for any conic section. What we wanted was standard form. And standard form is this, okay? Of course it's standard form. It's the form that when you look at it, you're like, oh yeah, it's a circle. I can see that it has x's and y squared, and it has a radius on the end. So we can answer our question now. So find the center and the radius. That's easy. Now that it's in standard form, it's easy. Center is 3 and -4. The radius is, well, this guy here is r squared, so it must be the square root of that, which is 7. And if you're not sure why, it's the root of that 49. Okay. It didn't say that it was a circle. I mean, it said in the question that it was a circle. It's always a nice idea to write down that it is definitely a circle, because when you finish, you know, it won't always tell you that. It might just say, find the shape. So given this form, we know that it's a circle. I'm going to give you a tip on how to solve that, but are we okay with how this went so far? The question's done. You've done everything it said to do. I'm going to assume yes until proven otherwise. What I want to mention is you actually could have told me that it was a circle from the very beginning. Maybe you couldn't have, but you can do this stuff. Look, I'll show you. I'm going to look up here. How do I know it's a circle? Well, circles have two special things. They have x squareds and y squareds, and they're equal to a radius. But more importantly, the x squared and y squared values, if the number in front of them is the same, they're a circle. So this is enough. This and this is enough to tell us that it's a circle. The x squared and the y squared, and there's no number in front of either one, just the 1. It's a circle, okay? We can do the same thing over here. Oops. We can do the same thing over here. This is x squared and y squared. There's no number in front of them. They're just 1 each. So it's going to be a circle. All right? So I'm actually not going to do example 2 because it's the exact same thing, and Mr. Tom did it on his video. I'll move to the next questions instead. But how do we feel about that so far? Sorry, I'm getting a million messages. I hope I'm not missing something.
All good.
Okay, so let's go ahead and see what happens here. The next example, like I said, I'm not going to do it. Ahmed Hossein raised a hand. Did you mean to raise your hand? Raise a hand usually means you have a question. There's also a thumbs up if you want to use a thumbs up. B and C and D are all ones that have been done by Tom. He also did not solve the entire question. So let me just make a note of what's going on here. It says, find all indicated points of interest for the ellipse given by this equation, which means that you need to complete the square to get it into general form, or standard form. And then you need to get the center and the vertices and the co-vertices and the foci and the eccentricity. So it's a massive question. If I was to ask you this, I probably wouldn't get you to do every single piece because it takes a long time, but I would get you to do some of it, of course. I'm talking about it now. I might as well do it. Even if you saw it on the video, it's nice to see it again. So let's go ahead and just knock this out, okay? First of all, first step, and if the instructions were given earlier, you need to group everything. So by grouping, I mean, okay, put the x's together. This is yx squared. Minus 18, that's our other x. And then I'll group my y's, 4y squared plus 16y. And I'm going to put my constant, 16, to the other side. All right, hopefully that's clear what I've done here. I've grouped my x and y's. Now, I have a little bit of a special thing going on here that's different than last time. I have numbers in front of my squared x and y values. So what I need to do, I'm going to think of this as being grouped because I think it really helps. Group these. Group them. Take out the common factor. And the common factor you're going to take out is based on these. All right, so I'm going to remove a 9 from the first one. So take the 9 out. What's 9x squared divided by 9? It's just this. What's negative 18 divided by 9? Negative 2. Okay, that's how we remove a common factor. You're just dividing out by that number. Now for this, I need to take out the 4. That of course leaves nothing next to the x squared. What's 16 divided by 4? 4. Okay, and now I've got this. Now I'm going to need to complete the square. So in order to save some space, I'm actually going to move this over. You can rewrite it if you want. I don't mean to mess you all up here, but I wanted to save a little bit of space. So I'm saving, literally saving some space on the page. I need to put a number here and I need to put a number here. What's my number going to be? Well, I need to complete the square. And remember, what it means is that I need to make a perfect trinomial out of this. I need 3 terms. So I need to divide this by 2 and square it. That'll give me 1. Now I could factor that nicely. Factor in the x minus 1 all squared. This one here, I need to make that a perfect square. What number divided by 2 squared gives back 4 exactly. Perfect. Now I am not allowed to do that on its own. I'm not allowed to just break this. I can't just add numbers as I feel like it, or else every equation would work out all the time. What I need to do, let me do this, sorry. What I need to do is negative 1 times 9 and put that on the other side. So negative 1 times 9 is positive 9. I need to do 4 times 4, and that's 16. Because remember, if it's in the brackets here, it always needs to be multiplied by this first. So it's kind of like 4 times 4 is that. Yeah, I need to include the thing on the outside of the bracket. Students forget that all the time. So be very, very careful about this. I'm going to put little stars next to these numbers. They're not the number that you see here. They need to be multiplied by the number in front in order to solve them. Okay, that's the trickiest part. The rest is just simplifying. Any questions so far? If there is, of course, you got to let me know. I'm going to fix this plus because it's staring at me. Plus. Okay, so you can go ahead and do this along with me. This is a 9. I need to divide the middle term by 2. So this is x minus 1 all squared. Plus 4, y, divide this by 2, so plus 2 all squared. And then simplify the right side. If you simplify the right side, that gives a 9. And we're almost done. Almost done. This is not in standard form because if we have this, numbers in front of here, we would expect that to be a circle or something. This number should be 1 on the right side. So to be safe, divide everything by that 9. Okay, we need to divide everything by this 9 here. That's because it's going to be in standard form. So let me just creep back for a second. I don't mean to throw you all off. I want to look at the instructions. Did we do what we said we we're going to do? Collect the x's and y's together. Yes, we did. Move any constants to the right-hand side. Yes. If x squared has a coefficient, x or y squared has a coefficient other than 1, factor them out. We did that. Complete the square. We did that. Write the left-hand side as a sum or difference of two squares. And simplify the right-hand side. We did that. That's part of completing the square. And then write the equation in proper standard form. So we need to force it into the form that we want it to be. So right away, we know that it needs to look like an ellipse. If it needs to look like an ellipse, then we need the right side to be 1. So we divide everything by 9. So divide everything by 9. And then we'll have our answer. So that gives us, you know, that'll cancel this out. It'll make 4 over 9. Let's just go ahead and do it, and you can see what I mean. This is a weird one, actually. So that's x minus 1 squared. I'll just say divided by 1 if you want. This gives us y plus 2 squared. This is a really weird example, I'm sorry. This on bottom actually would give 9 over 4. That almost never happens. I'm not sure why it did in this question. Equals 1. And now we have our final answer. The reason that was the way it was is because I divided this 4 by 9, but I needed to put it on bottom. So you need to put it on the bottom of a fraction. And you actually need to flip it. That's the only time in the entire course I think that happens. So let's not lose too much sleep over that. Normally the number cancels out nicely. So don't worry too much about that. Just go with me for now. Okay, so we can see that this is an ellipse, and I'm not going to get all the indicated points of interest. I'm just going to make a note. You know, for example, I could say my center now is 1 and -2. And if I wanted to, I could get the vertices, I could get the covertices, I could get the foci, and I get the eccentricity. But for this question, it's a little bit weird. So just be aware that you could start a new problem now, but it would be super long. I'm sure you can see that. All right. I'm going to move on to a few different questions after this that just basically completing the square over and over again. But how do we feel about this? Have I put you to sleep with my gentle, soothing tones? Or are you still with me? I'm going to assume you're still with me. You might be a little overwhelmed by this, but I think you'll see that it's not so bad. C and D were done by Tom, so I'm going to move on. So I assume you're all still with me. So these questions, I don't think these were done by Tom. They're all basically the same, honestly. Let's give it a shot. So for example 2, it says we need to identify the following conics. So is it a circle, ellipse, parabola, or hyperbola? So identify them. And then write each in standard form, except D. Why does it say that? What's D? Oh, D is a special case. Okay, are you with me? Are you alive out there? Hello, 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 hello.
Yes, sir, we are here.
Okay, you got to check every now and then. So what kind of conic is this? I can tell you right away it's a circle. How do I know it's a circle? Because I'm looking at the x squared and it has a 2. Looking at the y squared, it has a 2. But it's not, what's up, what's up? Nice to see you, Abdulaziz. Let's try to force it into the form that we're used to, which means move this to that side. So that means we have 2x squared plus 2y squared equals 8. And then let's see, we can divide this everything by 2. Because we don't want any coefficients in front of the x squared and y squared. That would give us x squared plus y squared equals 4. And now we have for sure 100% this is a circle. For the reasons I said before. What are the reasons I said before? You have a 1 in front of each of them, and you have a radius. Didn't ask us for radius, but we could give it if we wanted. Okay, so that one was pretty straightforward. Let's do a few more. Lots more, actually. Circle. Now, the next one. Can anyone tell me right away what shape it is? We don't necessarily, it's not so easy to know right away, but maybe some of you are thinking on the right level. What do you think it is? Any guesses? There's only 4 options. I can see 2 squared, so it's definitely not a parabola. So it's got to be an ellipse, a circle, or a hyperbola. No guesses? Or informed guesses? I'm going to move my x's over. I'm going to move my y's over, and let's see if we can make a better guess. It's not a circle, and the reason it's not a circle is because I'm looking in front of the x squared and in front of the y squared. Those numbers are different. So it's not a circle. I have a feeling it's an ellipse, but let's go ahead and see. So this is 3x squared minus 6x plus y squared, and I'm going to leave that 3 over there. Now I can see it's an ellipse. It's not in standard form yet, so I need to complete the square, but I can see that it is an ellipse because these numbers in front are different. Well, more importantly, look, I have a plus between the squared terms. I have a squared and a plus. It must be an ellipse. Okay, so let's go ahead and start completing the square. What do I do? First things first, take the 3 outside. What's 6 divided by 3? It's 2. Okay, leave some space. Plus y squared. Well, there's nothing to do for y squared. It's already squared. It's already completed. How do I complete the square? Let's see who's awake. What do I do over here? I divide it by 2 and square it. So that's a 1. Good job, Tarek. Now, what do I give on the other side? I don't give a 1 because it's inside this bracket. It's kind of got to get multiplied first and then go over. Yes, you have a 3. Now we're getting somewhere. So these end up being pretty quick once you're used to it. 3, complete the square here or factor it. So what 2 numbers multiply to give 1, but add to give -2? Or in other words, divide this number by 2. Much easier way. It's x minus 1 plus y squared equals 6. Is that in standard form? No, it's not. I need to divide everything by 6 now. I want this to be a 1 because I know it's going to be an ellipse, or at least it should be 1 on that side. So divide everything by 6. 3 divided by 6 leaves us with this. 3 over 6 is the same as 1 over 2, just in case you're wondering. This gives us y squared over 6 equals 1. And now I am finished. So you'll get used to this. You need practice, but they do end up sort of all being the same in a lot of ways. I'm going to pull out a few key values from this. This is the full question. I should probably write down that it's an ellipse. Ellipse. But I could ask you now, what's the center? And I could ask you, what's the vertex? Or what are the vertices? I could ask you any of these questions. So I'm going to write them on the side because sometimes, I'll just write it as an extension. Sometimes you're asked those types of things in a test situation. It's nice to remember how to get these things. So for example, let's see, what would the center be? 1, 0. I'm inclined to agree with you. Thank you. 1 and 0. What are the vertices? Well, right now I can see that the major axis is in the y direction. So I'm going to draw a sketch. Center is here. And my major axis is in the y direction. So I can say, all right, a squared is 6. That means that a is, what's root 6? I think it's just root 6. Root 6. You could say that b squared is 2. That means b is root 2. And you would start making your connections here. So for example, your vertices would be, if it's up and down is your major axis in the y direction, it would be 1 and root 6. Your other vertex would be 1 and negative root 6. For your co-vertices, you would go left and right from 1. So it would be 1 minus root 2 and 0. And you would have 1 plus root 2 and 0. These are all the things you've done before. That's why I'm not going through it in great detail. The foci, well, we would need c. C squared is a squared minus b squared. That means that c is 6 minus 2, so c is 2. 6 minus 2 and then the square root of that. Again, I'm going quickly because this is just an extension. I wouldn't ask you to do this entire thing in one question, but I want to review it. That means the foci, and by the way, the sketch is kind of like this. Foci are about here and there, roughly. And the shape would look like this. Foci is the center plus c and minus c, and up and down. So 1, go up by 2. 1, go down by 2. Okay? And then the eccentricity is c over a. Divide c by a, that's 2 divided by root 6. 2 divided by root 6 is root 6 over 3, if your calculator would give that. Again, I wouldn't ask all of that in one place. I just wanted to review it and show you that we've done all these things before. Now, some of you have missed classes. I wish there was something I could do to help that, but there's not really anything I can do. If you haven't caught the classes and haven't caught up, really that's not on me. It's not my problem. But there's lots of videos for you to watch again if you need to. But there's tons and tons of concepts. If you don't spend, I would say this stuff in order to really get it in your brain, this unit probably takes about 5 or 6 hours of practice outside of class to really get it in there. But 2 or 3 hours would go a long way, but they're tricky. Okay, I'm gonna keep going. We've got lots of time left and I want to do as many examples as I can. Any questions on what I've done so far?
No, sir.
Clearish? Okay, let's keep going then until I run out of energy. Let's see. This, what kind of shape is it? Do you want to give it a try? See if you can figure it out? I can see right away, just from the very first 2 terms, I know what shape it is.
Arabs.
Try again. Hyperbola, because the squared, one is squared. Well, they're both squared, but there's a minus between them. One is positive, one is negative. That means it's a hyperbola. So right away we could write hyperbola. And yeah, Tadek, it's just the minus that's the only thing that matters. So we need to get it into standard form. That'll prove to anyone who's watching that it is exactly a hyperbola. So I'm going to group my x's and y's. So I'm going to group my x's. Those x's are together. The y's, that's the only y. And I'm going to bring the constant to the other side. It's a negative for now, but don't worry about that. It'll fix itself. Let's bring the 2 outside, factor it out. Again, I need to factor this 2 out. That means I divide 2 by everything inside the brackets. So that would be a 6. 6 divided by 2 and squared is 9. I will add that to the other side. So negative 14 plus 9. Wait. What did I do wrong? This is a good time for a learning moment.
18.
What happened? 18. I need to take this 2 and multiply it by 9 before I ever get to that side. So 18. Now it's positive. Now I don't need to scream about it and freak out. Okay, so 2. And finish this factoring. Just divide that 6. Divide this by 2 and you get your answer here. Plus 3 squared minus y squared equals 4. And again, that's not quite right. Divide everything by 4 and the right side will be 1 and we'll have what we need. So I divide everything by 4 now. It's x plus 3 all squared. 2 divided by 4 is the same as 1 over 2. You know, just take your calculator, say 2 divided by 4. It gives me 1 over 2, or 1/2. Just take that fraction, put it on bottom. Now this is y squared over 4. And that's 1. So even though the very first thing I did without any work was figure out it's a hyperbola, this is definitely a hyperbola. But you'll notice that nothing really changed. It's still all about that minus. So final answer, hyperbola. Hyperbola. And now I could ask you anything about this. I could say, hey, what's the center? Or what are the vertices? You know, that's a very common way of asking this. Instead of asking for, this is a hint actually, for what you might get. I could say, hey, what's the center and what are the vertices? And stop it there. So you wouldn't have to really sketch it. You would just be able to get the center and the vertices. And then I could ask for just the covertices. I could ask for just the foci. You know, that's one way to ask you the question without making you do the whole thing. So let me show you an example of that. Let me show you if this is an extension. And again, that's not in the original question. I'm just trying to give you extra things to practice. My center, in this case, would be -3 and 0 because of the reasons that we've been talking about this entire unit. What about the vertices? We'll get a squared. For hyperbolas, which one of these is a squared? 2, it's the first one. So I'll write that right here. It's the first. That means a is √2. That means my vertices, I can get it right away. My transverse, my main axis is in the x direction. So I'll go left of the center by √2 and right of the center by √2. It's just -3 plus √2 and 0. You can say -3 minus √2 and 0. And you'd be done. You don't need a sketch if you don't want to. What about b squared? B squared must be 4. That means that b is 2. So I go up and down from the center to get my covertices. -3 and 2, -3 and -2. Again, up and down. You don't need a sketch for this if you understand the question. If you don't understand the question, you need to go back and do more practice. C squared. C squared for hyperbolas is a squared plus b squared. You should remember that. So that means that c squared is 2 plus 4, because that's a squared and b squared. That means it's 6. C squared must be √6.
Sir, I have a question.
Yes.
The a squared, it must be the biggest number, I think.
No. For ellipses.
8.
For ellipses. So that's the big difference between an ellipse and a hyperbola. Well, there's two. One is the minus. But in terms of, you know, when you're getting A and B, the A for ellipses is always the biggest one. The A for hyperbolas is always the first one.
Ah, okay.
So look, over here, the first one was 2. It didn't matter because this is an ellipse. So we take the biggest one. Yeah?
Yeah.
For hyperbolas, the first one is A. So it looks like a mistake, but it wasn't a mistake. It was because of the difference between ellipse and hyperbolas.
Yeah.
So foci,
Okay.
let's think about this. Foci, for hyperbolas, again, maybe you need a little sketch here. What is this going to look like? It's going to look like this. The foci will go left and right, just like the vertices will go left and right. So I'll go left and right from the center by √6. Honestly, it's not difficult if you get this. Go -3 is what my x value is. Take away c, √6. -3, add c, √6. And these are my answers. If you want to get the asymptotes, that's also very straightforward. Well, it's not straightforward. These are very complicated questions. But because we've done so many, they should be easier now. The asymptotes, let's see who's been paying attention since yesterday. Asymptotes, what's my formula going to be? Anyone want to hazard a guess here? I'll give you a hint. asymptote should look like this. Plus or minus the one that's related to y. Something to do with the y over something to do with the b. Oops. Something to do with the y over something to do with the x. Well, the y term is this one, the x is this. Or in other words, it will be b over a. So this one's a tricky one if you're not sure what I'm talking about, but let's just steal. So this line is going to be y minus k, which is just the y, equals plus or minus, in this case, it's 2 over root 2. That's not proper, but I don't really care right now. And then x plus 3. Okay, so this would be like the longest question I would say in the entire course, and I mean that. It's the longest question in the course. Tarek, I'm not sure how you got your numbers. Where did the x minus 4 come from? Because we're stealing this from this, yeah? Maybe you looked in the wrong place. B squared, yeah. So remember, we have our formula for the asymptotes. It's this. This is our formula for the asymptotes. So we take our center value for the y part. You did that correctly. You don't need to add the 0. You can just have y. X minus h is already given in the original question here, x plus 3. So you just steal that, okay? And then for the slope, you just go up by b and over by a. Or in other words, 2 over root 2. I'm not going to bother to rationalize that. Okay, so I want to be very clear. I would not ask a question this long on a test. It would never happen. I wouldn't even ask it on the final. No one would. But the reason I did it was now you have a full question. Okay, you have all the pieces, and I could ask you any piece, and you should be able to handle it. So you're given something in a general form. You go through the process of completing the square and get it standard form. Once it's at standard form, it's like the questions we've been doing the entire unit. It's in standard form. Okay, give me the center. Give me A and then vertices. Give me B and then your co-vertices. Give me C and then your foci. The steps are the same. So I feel like we've been doing this topic for a year. We've only been doing it since Sunday, but you know, there's a lot to keep in your head. All right, so clearly you need to do the practice if you haven't been keeping up with it. All right, D is a little bit of a special one. I'm gonna move on. D is, let me just move the constant to this side, is a special case. And I almost expect no one to be able to get it, but does anyone want to give me a guess at what shape this is? Circle? Nope. Circles need to have squared x's and squared y's. This is a very special case. You could graph it on Desmos if you wanted to. It's a very special case of a hyperbola. This is a kind of, I don't know if I'd call it a challenge question. It's just like a bit of a random question. And I mentioned that way back. I said that xy equals c is something sometimes you see. This is a case where we saw it, but it's like kind of out of left field. If you're ever really, really not sure, you know, you can always go xy equals c. Oh, I have to rearrange it. Anyway, I'm not going to give it, but I'll graph it while I'm talking about it. C divided by y. Why is that not working? Anyway. So C, yeah, sorry. It's because I didn't define C. Oh, 36. What am I doing? All right. Take making the keyboard up. XY equals 36. Technology's out to get me today. Yeah, here we go. That's what it looks like. So if you wanted to graph it, you could. You know, have your phone in front of you, just graph it. If you're not sure, it'll tell you what these shapes are. You can kind of cheat in that way if you're just looking for the shape itself. I didn't tell you to cheat. It's not actually cheating unless you're asking other people for the answer. But you're allowed to go get the answer yourself, or sorry, lead yourself to the answer through Desmos. So I'll give you permission for that. All right, anyway, that was a quick question. It's a hyperbola because of this rule. If it's x times y equals some constant, then you're going to get a hyperbola. Okay, let me look at E. I'm going to multiply these through. Let's see what it gives me. 4y squared minus 28 equals 16x plus 24y. Okay, let's see who's paying attention. Let's see who's, you know, going to get the higher marks here. Who's going to maybe be able to get some good multiple choices out of this. What shape is this? Can we tell already? Take your time to think about it before you answer. Oh, ooh, I'm seeing a parabola. Someone's saying parabola. Anyone else have a guess about this? Is it just Tarek? He's the only one who wants to talk. Fine, no judgment. A little bit judgment. I would say parabola. Absolutely. That was easy to crack me up. Parabola, yeah. And the reason we know is that there's a squared here and nowhere else. So we have y squared form. And if we needed to pick that apart, it would have a, I'm going to go a little further to figure out what kind of shape it's going to have. I know it's definitely y squared form, but I need to get it into its standard form. And this is a little different. So we need to get it into y squared form, which looks like this. You might not remember this very well because it was at the beginning. But we need to force it into this shape. Yeah? So we need our y squared stuff on the left, and we need the rest on the right. So let's do that. Let's make sure that our y's are on the left, and our x stuff and constants are on the right, and see how this works out. So let's move the y's over, move the constants over the other way. 4y squared minus 24y equals 16x plus 28. Now you might feel a little stumped. Let me help you walk through this. The right side right now, there's really nothing for us to do. We can't complete the square because there is no square on that side right now. There's just x's and constants. So just don't touch them. On the left side, you can see here, hopefully, we can complete the square there because we've got a square and we've got a linear term. So we can make that into a perfect square. I'm going to take the 4 outside. It's going to give me y squared. 24 divided by 4 is 6. I'll leave some space so that we can think through this. Okay, so those of you that have been paying attention should know how to do this now. 6 divided by 2 and squared, plus 9. What do I add to the other side? 4 times 9. 4 times 9 is 36. And then I need to go through my regular process here. It's still y minus 3 all squared. Notice something I didn't mention. Many students keep the square here because they see it there and they're like, well, there's a square here, so I must put a square there. That's not how it works. The square moves. You're taking this whole piece and you're factoring it, putting the square here. By the way, for those of you that forget why this works, really what we're doing is we're factoring this. This is what we actually are doing, but we're taking shortcuts to make life easier. And we can see that that's what that is, okay? So when we're completing the square, we're actually factoring it as well. Okay? So the right side, there's not much to do. We're going to play with the constants. What's 28 plus 36? 64. I forgot the x. Okay. And is this in the form we want? Does this look like this? Nope, not quite. What do we need to do? We're going to need to do two things. We're going to need to divide everything by this 4 in order to get rid of it over here. And then we're going to need to do a little common factoring. So this is a little trickier question, but it's still not too much. Divide everything by 4. That would be 4x. What's 64 divided by 4? 16. All right, I'll break here for a second just to recollect our thoughts. Let me summarize what we've done so far before we finish. In the beginning of this question, we have a y squared, no other squares. That means that it's a y squared form parabola. And so if it's a parabola, we need to get it into the parabolic form. We need to match this equation. So I'm just going to complete the square and do all that stuff to complete the equation. The reason I divided by 4 here is because there is no constant in front of this equation. So I need to make it 1. Divide everything by that. And now I need to match this form. I need to pull the constants outside. Well, what's my common factor between these two? 4. Yeah. So that'll actually be my 4p. I can take that outside. So my left side, y minus 3 squared, that's perfectly fine. If I factor out a constant, I end up with this. And now, ladies and gentlemen, c'est fini. That is certainly a parabola. It's even in parabolic form or standard form. And we can even say what it looks like. You know, as an extension, I could ask, what is the vertex? I could say, what's the vertex? That's our center really from the other ones. Our vertex would be -4 and 3. And then you might remember, I need focus now. So I need to figure out what P is. So 4P is equal to 4. That means P equals 1. Remember this once upon a time? That means our focus is what? Well, this is y squared form, so it looks like this. My vertex is over here. My focus is inside. So I need to go right by P. The focus is going to be -3 and 3. Lots to keep in mind. Lots to remember. Don't get lazy. Do the practice. And what else? Do you remember this other special piece? The other special piece was the directrix. So let me try to summarize. For parabolas, you need to know your form. Your form in this case is y squared with a positive p that opens to the right. If it opens to the right, the focus is inside. So you just go over 1 by the p value. So just add 1, you get your value of the focus. If you go left by p, you will get your directrix. So just go left from the vertex, which is -5. And so your directrix is x equals -5. And that's everything I could ask you about the parabola. Again, if I do the extension with these, they're the longest, I think the longest questions in the whole course, because there is a ton of work. But I'm telling you right now, I'm not going to ask you to do every single bit of this. I'm just going to ask you a piece. But if you don't know how to do them, then you can't, how are you going to be able to do all the pieces? You know what I mean? So this, that's that. I'm going to keep doing examples, but they're all basically the same. Any questions? I feel silly even asking that because there's so many steps, but anything you want me to go back through on any of this? No. Some students are like, no questions, but please, kill me now. Just put me out of my misery. Okay, let me do as many examples as I can, yeah? Because I think this, you'll see the patterns once you do enough. If you don't do enough of them, you can't see the patterns. It's like anything. like if you play a musical instrument, in the beginning, everything is difficult. Like if you play piano, your hands don't even feel like they work. You're like, seriously, I can't even make my right hand work. You're gonna make me play my left hand and my right hand at the same time? You're crazy. And then after you do practice, you're like, oh, I can play Mary Had a Little Lamb perfectly. Or you can, you get better and better at things. You see the patterns. What used to be difficult is now you don't even think about. You move on to the harder stuff. Anyway, just a little motivation. Practice 1. I think that's it. Yeah, this is the last bit of mixed practice we have, and then tomorrow we'll do the word problems in the assignment, of course. Just so I'm clear, I think I said this, but the assignment will still be 1 page. I always like to keep it 1 page, but it will not cover what we do tomorrow. Of course, that wouldn't be fair. It could cover something from today, but it will not cover anything from tomorrow's class, of course. So no word problems on the assignment. You'll have word problems on the test. Okay, let's go ahead and do this. So I'd like you to do more work than I'm doing now. So identify the conic. So is it a circle, parabola, ellipse, hyperbola, and write it in standard form, which it clearly is not so far. Can I tell you the questions? No. What do you mean? No, it could be anything from this unit. So anything, absolutely anything. I haven't made the assignment yet. I'm just going to go through and pick whatever. Yeah, good try. It's always, you'll never get an answer if you don't ask. Like my mom always said, the worst they can say is no. So no. Identify the conic. What's the conic? Is it a circle? No, because
Correct.
these two numbers are not the same. Is it a ellipse? Yes, because there's a plus, and both of these things are squared. For sure, it's an ellipse. I'll double check that when I finish making it in standard form. If you don't know ahead of time, don't worry. You can always get what it is after you're finished, when you're done making it in standard form. But it's nice to know ahead of time. So what do I need to do? There's very little to do. This is almost done. I can see that it can't be a circle because a circle would have a radius, but a circle would not have a number in front of any of the squared stuff. So I need to divide everything by 2. That's x squared over 2 plus y squared equals 1. And now for sure it's an ellipse. Those are my 2 answers. I'm not going to do the extensions. I could, of course, ask you. You could say, what's the center? 0, 0. What's the vertices? And blah, 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 blah. But I'm not going to do that. You've got enough practice now. Okay? So this might not help you, but I like to think visually sometimes. So the ellipse has this form. Something squared plus something squared equals 1. So an x squared and a y squared term. And then you have something on bottom and something different on the other bottom. Again, I don't know if that helps you or not, but sometimes I like to think just in basics. So how do you know it's an ellipse? It looks like that. Let's do the next one and do as many as I can. Of course, there's only 1, 2, 3, 4, 5, 6 on the page. Let's see what we got. All right, before I start, can we tell? Parabola? Nope, not a parabola. Can't be a parabola. How do I know? Because you can't, parabolas only have one of them squared. X squared or y squared, not both. Ayesha is saying ellipse, and I'm inclined to agree with her. Let me just see, how would I know? Yeah, it's got 2 different numbers in front of the squared terms, and there's a plus in the middle. So yeah, I also think it's an ellipse. You don't need to know ahead of time. It's just a good idea to try to know it ahead of time. This is x squared plus 2y squared equals 8 minus 8y. I'm going to move it to the left side. Those are all my x's. 2y squared plus 8y equals 8. All right, so now I can definitely see it's an ellipse, but I'm going to wait till the end to write that down. I need to complete the square on the middle here. Take the 2 outside, That's this. Divide 4 by 2, square it, I get back 4. That gives me 8. And add what? 2 times 4 is 8. So that should be plus 8. Okay, 8x squared. Wait a second. I'm just looking at my notes here. Oh yeah, okay. Yeah. I think we're on track. Squared plus, complete the square on this, so 2. Divide the middle term by 2, it's a 2. Sorry, divide the middle term, yeah, by 2, it's now 2y, or just 2, y plus 2, square it, 16. What do I do now? Same as before, divide both sides by 16 because I need the ellipse shape, or I need a hyperbola shape, or I need the general shape. I know that these two numbers are different, so I've got to divide it out. Let's see, 8 divided by 16, 1 over 2. 2 divided by 16, 1 over 8. You know, just put these in your calculator. 2 divided by 16 gives 1 over 8, yeah? So that's why I get this 8 on bottom. 1, now I'm finished. Now it's clear, or it should be, I think it's clear. That might not mean much, but it should be clear to you that this is an ellipse. How do I know? Because there is a plus, oops. There is a plus in the middle, and we can see that there are 2 different numbers on bottom here. If they were the same numbers on bottom, then really it would be a circle. If it was a minus in the center, it would be a hyperbola. So hopefully I'm giving you enough review to know the differences. Any questions on that?
No.
Okay. I shall continue. I'll keep that there so you can look at it. What about the next one? Let's see what it is. What do we have? We have x squared. We have y squared. Ooh, and they don't have numbers in front. They are both the same number in front. And there's a plus. I know enough. I've got my puzzle. What is it? Anyone want to guess? I wish I had like some bonus. I need to come up with some sort of game that I can give you a little bit of a bonus to answer the questions. Circle. Circle. Maybe the bonus is that on the test there will be a multiple choice that asks it, you know, and the bonus is that you actually get the marks. I guess that's not a very good bonus, is it? Bonuses shouldn't be worth marks. Anyway, or they shouldn't take away marks, I should say. Let's do this. You can try this yourself and tell me what your final answer is, okay? But I'll do it with you. I just won't talk about it. Oh, it's done. Okay, so before I go any further, maybe you tried that yourself, maybe you didn't. Hopefully you're still paying attention. Let me give this a little space just because I can. What would happen if you divided this by 26? Some students go on autopilot and they divide this by 26. You know, what would happen? Let's just say you chose to divide it by 26. Well, what you would get, and I'll erase this after, is you would get this. Which looks like an ellipse. it's in the form of an ellipse, but what you'll notice is that 26 and 26 on bottom, well, an ellipse is supposed to have two different numbers down there because for an ellipse, we're supposed to either have like, I don't need this, it's either supposed to be stretched in the x direction or it's supposed to be stretched in the y direction. But this means that it's not stretched in either direction, it's stretched equally in both directions, which that is a circle. That's what a circle is. It's like a perfect ellipse, an ellipse with no eccentricity. So there's no reason to put it into this form. You could put it in this form if you wanted to, but that's not what we call standard form for a circle. This is standard form for an ellipse. A circle is a special case of the ellipse. I hope that makes sense. In any case, I'm just trying to tell you, for circles, if you've got the same number here and there, there's no reason to divide it by 26. You've got everything you need. It gives you the circle, it gives you the center, it gives you the radius. You know, don't waste your time. If you do happen to divide it by 26, though, you'll see that it's a circle. Okay, D is a bit weird. D doesn't have any squares. So I'll put my little question mark man here. It's a line, and I don't know why it was given. We don't need to do that one. I'll just quickly do it for you so you can see, but I don't know why it was part of this. I don't know why it's part of this practice set. It's not helpful. You can see they cancel, and 3y equals 5x, or y equals 5 over 3x. Maybe it's just trying to review, but not very helpful. I'm not sure why it's in this group. So we'll skip it. We've only got 2 more questions left, and we got 5 minutes, so that's actually good timing. We'll finish. What's the first one? Well, let me expand that left side first because it's more clear. And I'll keep the right side the same. Does anyone want to guess which type this is? Don't jump to conclusions here. We might have a little bit of a special case going on. Do you see anything strange about the left side and the right side? For those of you that are still paying attention. What's going on here? Well, on the left side, I can see that there's a y squared, 2y, and a 1. On the right side, I see x squared, another y squared, and a minus 1. If I was to bring that to that side, I would get y squared minus y squared. So in other words, if it's on both sides, they cancel. So Ayesha, you got it. It is a parabola. Because when we work this out now, it's 2y plus y, plus 1, x squared minus 1. That is an x squared form parabola. It's x squared form. So we need to match this. And I have them all in my head, but you would have a formula sheet on the test. The formula sheet, by the way, I say on the test, what I really mean is it's widely available right now. If you go into D2L, I may or may not finish the last question, but I'll see. If you go into D2L and you go into content, under course information are all the formulas, and there's actually not that many in this course. The formula sheet is there, and you can, have this to the side. So everything you need would be there. Your parabolas, circles, ellipses, and so on. And you can see that for parabolas, this is your y squared form, this is your x squared form. Okay, so you should be okay. Everything's labeled very clearly. You should be able to reference everything you need. Even the C's are there. You just need to know what they mean, okay? So hopefully that is helpful. Let's finish this question. That means I have x squared, I'm just flipping the sides, equals 2y plus 2. So x squared is 2 outside of y plus 1. You can check that yourself. It's not that much effort. That's parabola. Got 2 minutes left, so I'll do the last one. I just won't talk it through as much as I normally would. I can see that this is a hyperbola. I'm going to group the x terms. I'm going to group the y terms. I'm going to factor out the minus, which you can check yourself after. Factor out a 2. Complete the square. Factor out a 3. Complete the square. This gives me a +4 here. Again, I'm just making sure you have the notes for this. And then this gives me a 16. On this side, I would have +8. For this one, I would have -48. So make sure you understand where that minus comes from. You can take a look. This is x + 2 all squared, -3, y - 4 all squared equals 6. Divide both sides by 6. That gives us x + 2 all squared over, oops, all squared over 3 minus y - 4 all squared over 2 equals 1. And so that is indeed a hyperbola because I see my minus. And I'm done. Okay, right on time. So what I'd recommend is that you make a note, be careful that you know what happened with this minus. I factored a minus outside. So you'll see the minus here. That factoring the minus out here changed the sign of the term there. But just, go back through that if you need to. Other than that, that's it. I'm going to stop the recording here. Bye-bye, everybody. See you next time.